Good morning, Math World. How's it going? Hope you're doing well. We're on 11.3 now. We're talking about equations in two variables. One variable would look like, well, actually it says right here, before. What did we learn before? You found solutions of equations in one variable. So 2x equals 7. How many variables do you see in that equation? There's only one, x, right? To solve that, we know that we could divide both sides by 2. That would cancel those out. And x equals 7 divided by 2. What is 7 divided by 2? It's 3.5. So, x has to equal 3.5. It can't equal anything else. But today, right now, we're going to talk about finding solutions of equations in two variables. So if I had a p plus 2 equals 3 minus r, is there only one thing that r can be? Just like over here, there was only one thing x can be. 2 times 3.5 is the only thing that will get you to 7. But here, if I put a 1 in for r, let's see what happens. P plus 2 equals 3 minus 1. 3 minus 1 is 2. I've got a plus 2 over here, so I'm going to subtract 2 from both sides, that and that, right? And so those cancel out. P equals, what's 2 minus 2? 0. So if r is 1, hello, then p would equal 0. That is a solution to this equation in two variables. R would be 1, and oftentimes we write this as an ordered pair, and p would be 0. So check it out. Your answers to pretty much all these problems today are not going to be just one number, x equals 7. Or whatever. It's going to be two numbers. And not only that, but you can have multiple solutions to the same equation. Where the first one, 3.5, was the only solution. Now, you can have multiple solutions. Because does r have to be 1? No. We can make r be 2. And then what would it be? This would be 3 minus 2. Which would be 1, and then we'd subtract 1, p would be negative 1. And as it goes up, if r was 3, do you see a pattern here? These ordered pairs, if r was 3, 3 minus 3 is 0, minus 2, negative 2. Ooh, yeah, there's a pattern. Okay. So, why are we doing this? So you can find how long it takes to pay back a loan, as in exercise 29. So, let's get started here. Inline skates. At a sports store, it costs $7 per hour to rent inline skates. Plus, or rollerblades, apparently, plus $10 for the safety equipment. So, the total cost can be modeled by this equation. Now, we've done some of this before. You guys could have set up this equation, right? The total cost, C, equals your one-time cost of $10 for the safety equipment plus $7 per hour, right? $7 every hour that you use them. Now, this equation, is this an equation in one variable or two variables? In two variables, right? H and C. We don't know how many hours you're going to be out, so we don't know the total cost. But we could do some theoretical plugging in for the hours and find out. So what are some possible costs for renting inline skates? Well, this is a simple example of finding solutions of an equation in two variables. It's an ordered pair, like I've been doing. It's an ordered pair whose values make the equation true. For example, 2 and 3 is a solution of x plus y equals 5 because 2 plus 3 equals 5. Can you think of another example of a solution to this equation, which is in two variables, right? 1 and 4. Right? Or 0 and 5. Those would all be solutions to that equation. Okay, sounds pretty simple. Let's check this out. make a table for c equals 10 plus 7h to find some possible costs for renting inline skates. How do they make a table? Well, they substitute, they're going to say h is 1. And if h is 1, they plug it in and they solve for c. c is 17. So here's the solution column right over here. If h is 1, c is 17. And typically, how do you know which one to put on which side? Why not 17, 1? Well, typically, in fact, all the time, if you have a function rule, remember that's another name for this equation, if it's solved for a variable, right now this is solved for c, because c is all by itself, then that's the one that goes on the right side. You plug in numbers into the vending machine side, right? And it spits out whatever that's going to be. So the number you plug in first comes first here in the ordered pair. So it looks like if you rent the skates for 2 hours, you're going to pay $24. 3 hours, $31. 4 hours, $38. All right, use the solutions to make a table. Hours skated, 1, 2, 3, 4. Total cost, 17, 24, etc. Okay, but then it asks, how many hours can you skate if you have $35? Well, if you have 35, you can definitely do 1 hour. You can definitely do 2. You can do 3, but you can't do 4. All right, fair enough. Let's try another one here. Okay. Can you tell whether or not this solution that you're given is a solution of this equation? Well, the first number in an ordered pair always represents the x. If your equation has an x and a y in it, then the ordered pair always is ordered like x and then y. So we've got to put 7 in there, -6 in here. So that's what they do. 3 times -6 is a positive times a negative, so that's -18. So 7 plus -18, that's the same as 7 minus 18, which would get you to -11. Is -11 the same as 14? No, it's not. So the ordered pair is not a solution. All right. When finding solutions of an equation, it can be helpful to write the equation in function form. Function form means, I've been using the example of a vending machine a lot, right? So function form means you have an equation, and you might have the 2 minus x equals y plus 3. Well, you've got numbers and variables on both sides. So function form, to really function with this well, is to solve for one of the variables. And if there's an x and a y, you always solve for y. It's just how we do it. So check this out. And sorry, this has a little highlighter that bled through, but this is in function form because it's solved for y. It functions really well because I can now choose values for x, and I can just concentrate on simplifying that side, and then I know what y is. This right here would take more work. If I plugged something in for x, I'd have to do a bunch of side switching and whatnot to figure out what y is. So this is not in function form. It is an equation in 2 variables. It's an equation because there's an equal sign and there's 2 variables, but it's not in function form, not vending machine form. So the best form to have things in is this function form. Also, if you've got this term with an x in it, put it first and then the constants. Remember, this is a variable term and this is a constant. 15 is a constant because it's always 15. Okay? Put the variable term first. So notice, well, let's take a look at this example. Solve the equation, blah, 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 for y. List 4 solutions. To solve for y, let's be clear about this. Solving for y means not to find out the number that y is, but to get y by itself. So here in this example, we're not trying to find what y equals. No. Because y could be a number of different things, right? You could find lots of solutions to this. We're just trying to solve for y, meaning get y by itself, put it in function form. So, and then we're going to talk about solutions. So number one, put it in function form. You started with this. How to get y by itself? Subtract 4x from both sides. Don't divide, because this isn't 4x times y. There's just a 4x sitting over here. Let's subtract it from both sides. So, there they got it. Y equals 15 minus 4x. Now, apparently they don't put it in the format that I was just telling you about, but let me show you in, they might throw it at you in the next section here or something, but it might just be for later on in math. But in math, we like to arrange this with the negative 4x first, plus 15. What I just wrote is the same as that, right? So this format is the better format. And you'll see why when we start graphing these, okay? In fact, I can say with confidence now, you will, in the next couple sections here, be asked to put it in this format. So for those of you that might be scratching your head over this, y equals, isn't that a positive 15? And isn't minus 4x the same as plus negative 4x? Yeah, it is. And so if there's a plus, I can switch things around. Okay? If I would have done this, y equals 15 minus 4x. Okay, well, I'm going to put the 4x first. Y equals 4x minus 15. These two are not the same. Subtraction is not commutative. There's a subtraction between these two terms. You can't just switch them around. But Mr. Anderson, isn't that what we just did? No, there's a trick here. I turned it to a plus a negative 4x, which is the same as 15 minus 4x. And now, since there's a plus there, I can switch this one over there for that one. So now I've got a negative 4x plus 15. Because addition is commutative. It can commute around to whichever order you want it to be in. And aren't these different? This one says y equals negative 4x plus 15. This one says y equals 4x minus 15. They are very different. So, now we've got to talk about solutions. Well, let's just do a table here. Input, that's the x. Output, that's the y. We'll just do a couple of these. So, let's input 0 for x. Why not? That's really easy. If x is 0, negative 4, oh, you can't even see all that, sorry. Negative 4 times 0 is 0. That's gone. Plus 15. So y would equal 15 if x was 0. If x is 1, what's negative 4 plus 15? Well, it's the same as 15 minus 4, so it's 11. Y would be 11. If this was 2, that would be negative 8. 15 minus 8 is 7. So as x gets 1 bigger, I might have to edit that out. Okay. As this gets bigger, y is getting 4 smaller every time. All right. Finally, that's how you solve an equation for a variable, and then you can list solutions by just picking input values and seeing what the vending machine outputs for you. Write them as ordered pairs. Do not forget your parentheses when you're writing as an ordered pair, okay? And let's just take a quick look at that loan example. Where is that? Exercise 29. In order to buy a house someday, you guys are going to have to get a loan, unless you hit the big bucks and you pay for it by cash. But in that case, if you hit the big bucks, you'd probably buy a even bigger house and still get a loan, because we always want the biggest, best house we can buy for some reason. Anyway, 29. Your friend agrees to lend you $15 to buy a toy rocket. Thanks, friend. You promise to pay your friend 75 cents each week until you have paid back the full $15. You use the equation P equals 15 minus 0.75n, where P stands for the amount of money in dollars you have left to pay. Okay? So P is what you still need to pay. And N is the number of weeks. To find the number of weeks it takes, or to find the number of weeks it takes to pay back your friend. So, you have to pay $15, right? P stands for how much you have to pay. You have to pay $15 minus whatever you've paid so far. And whatever you've paid is 75 cents every week. Right? So you're having to pay $15 minus whatever you've already paid. So in 1 week, I'm going to make some ordered pair solutions here. After 1 week goes by, you've paid, we'll put a 1 in here for N. That means you've paid 75 cents. What's 15 minus 75 cents? $14.25. After 2 weeks, 75 times 2 is 1.5, so 15 minus 1.5 is 13.5. Because if I put a 2 in for N and I do the math, P would equal 13.5. Now this is dollars, so I'm going to put a 0 there, $13.50. So how many weeks, the problem says P is the amount of money in dollars you have left to pay, and N is the number of weeks. To find the number of weeks it takes to pay your friend. Well, class, should I just keep going? 3, figure it out. 4, figure it out. No, because that's going to be like, take a long time and be trial and error, right? What we really want to know is, we want to know when the amount I have to pay is 0. Because that means I totally paid it off, right? Use your brains here, okay? This represents the amount you have to pay. The amount you have to pay equals $15 minus however much you've paid already. So we want to get it to 0, and we want to know how long that's going to take. So let's take this and set P to 0. What if we have 0 left to pay? 0 equals 15 minus 0.75 N. Now we're going to just do some math to solve for N. So I'm going to, because that's a minus, I'm just going to add the 0.75 N to both sides. So now we have, I'm going to move over here a little bit. Now we have 0.75 N equals 15. Okay? Now divide both sides by this 0.75. I don't feel like getting my calculator out, being lazy. I know that 15 divided by 0.75 is 3/4. 15 divided by 3/4 is the same as multiplying by the reciprocal, 4/3. 15 times 4/3 is, 15 times 4 is 60, divided by 3, 20. Yeah? So, if you pay 70 cents or 75 cents a week, how many weeks is it going to take you? N stands for the number of weeks. It's going to take you 20 weeks. Let's just check that. If I put a 20 in here for N, this should come out to 0. P should equal 0. 0.75 times 20 is, well, what's 3/4 of 20? It's 15. So, because 0.75 is 3/4, right? So 3/4 of 20 is 15. 15 minus 15 gives you 0. You have 0 left to pay. Ba-boom! Dunzo. All right. So those are equations in 2 variables, and not sure what these guys are for, but I bet you they have something to do with skateboard wheels. Nifty. Have a good time.